Hello everyone, this is question number 16 of Irodov. This is the question of maxima and minima, and the question is two particles 1 and 2 move with constant velocities v1 and v2 along the two mutually perpendicular direct straight lines toward the intersection point O. At the moment t is equal to 0, the particles were located at the distances L1 and L2 from the point O. How soon will the distance between the particles become the smallest? What is it equal to? So in this question we have to find out the minimum distance between the two particles which are moving toward the intersection point along a straight line. The situation is like this. This is particle number 1 and this is particle number 2. They both are moving along the straight lines toward the intersection point O. The particle 1 is moving with velocity v1 and the particle 2 will be moving with velocity 2. At certain instant of time, they will cover the distance v1t and v2t. So the situation is like this. This is your particle number 1. This is your particle number 2. Particle number 1. It is moving with, and this is the point of intersection O. It is moving with velocity v1 and it is moving with velocity v2. After a certain interval of time, it will cover the distance v1t and it will cover the distance v2t. This distance from here to here is L1 and from here to here is L2. The distance between these 2 points at time t is equal to t is this. This remaining distance will be L1 minus v1t and this distance will be L2 minus v2t, and this with the distance which should be minimum. So the S will be under root L1 minus v1t whole square plus L2 minus v2t whole square. Squaring both sides, L1 minus v1t whole square plus L2 minus v2t whole square. To find the maxima and minima, we have to differentiate our equation with respect to the time. In this case, there is a time. So we have to differentiate this S with respect to time. So we will differentiate it with respect to time and then put it equal to 0. By differentiating first time and putting it equal to 0, we will get the extreme points. Either it will be maxima or minima. But to confirm it is maxima or minima, we have to again differentiate it with respect to the time. So by differentiating this equation, we get first differentiating with respect to time, we get 2s ds by dt is equal to v1t, and then again differentiating this thing will be minus of v1 plus 2 L2 minus v2t, and again differentiating we will get minus v2, and we will put it equal to 0. So on simplifying this, we will get L1 minus v1t, these two will get cancel out and it will become positive there, so it will be minus v1, it will be equal to L2 minus v2t and v2. On simplifying, we will get L1 v1 plus v1 square t is equal to L2 v2 minus v square t. Now V1 square T plus V2 square T will be equal to L2 V2 plus L1 V1. T will be equal to V1 square plus V2 square L1 V1 plus L2 V2. T will be equal to L1 V1 plus L2 V2 upon V1 whole square plus V2 whole square. So this is your time. It can be maximum or minimum. So to find out that this time is maximum or minimum, we have to again differentiate this equation. This is the required time. Now we have to find out the minimum distance. Now for finding the minimum distance, we have to put this minimum time in the equation number 1. So it will be equal to L1 minus V1 bracket L1 V1 plus L2 V2 upon V1 whole square plus V2 whole square, and then again square plus L2 minus V2 bracket L1 V1 plus L2 V2 upon V1 whole square plus V2 whole square, then again square. On solving it, this V1 square will be multiplied by this L1, it will be V1 square L1, and again we will multiply this thing, it will be V1 square L1. This minus sign and this thing will get cancelled out. We will be only left with V2 square L1 and minus V1 V2 L2, and then whole square. Similarly here V2 square will multiply by with this L2, and this V2 will multiply by this. It will be in negative and it will be in positive. They both will get cancelled out. So we will be left with V1 square L2 minus V1 V2 L1 upon V1 square plus V2 square whole square. Now we will take out the V2 common here. Taking out, it will be V2 whole square V2 L1 minus V1 L2 upon V1 whole square plus V2 whole square, then square, plus again here we will take out V1, it will be V1 square V1 L2 minus V2 L1 upon V1 square plus V2 whole square. So this is our equation, and we will again simplify this equation. We will get V2 whole square plus V1 whole square. This is V2 L1 and here is V1 L2, but there is a square outside, so there is nothing to worry about. You can write it as we know A minus B whole square and B minus whole square are the same thing. So you don't have to worry about that. It is V2 L1 minus V1 L2 and this is V1 L2 minus V2 L1. Both are the same thing. So it will be equal to V1 L2 minus V2 L1 upon V2 whole square plus V1 whole square under root. So on solving, we get this gets out and this also gets out. V1 L2 minus V2 L1. This V1 gets out by 1 minus. So as we are calculating the distance, so the distance cannot be negative. So if the quantity after minus will be greater, so it will be negative. So we will put mod here. So this is your required answer. Your answer can also be V2 L1 minus V1 L2. So this is your minimum distance at any time. Thank you very much. This is for question number 16 of Irodov. If you have any query regarding this question, please comment down below. Also subscribe to my channel and also follow me on Instagram. Thank you very much.